Hiya, I'm just going to have a look at query 15 from Appendix 10 of the Advanced AH Course Spec. Now, weirdly, this links up to example 9 in Appendix 5. So I guess I'm actually kind of looking at example 9 in Appendix 5 initially, because I'm going to look at how we even go about designing this query. So the task was display the hotel name, star rating and price per person for the most expensive hotel in the hotel's database. Now, it's a very small data set, so obviously we could look easily and find the most expensive hotel, find out what that price is. But it can be, potentially helpful to imagine that it's a considerably larger data set with thousands of things, where that sort of thing would take a while. Anyway, let's have a look at how we design it then. So we want to display hotel name, star rating and price per person. So if you look at the structure of the tables, they are all just in the hotel table. So initially we know that it's going to be from hotel. Yeah. Now what else do we know? We want to check if the price per person is equal to the most expensive price per person. It's kind of like doing a find a maximum algorithm. We're checking where the price per person equals most expensive. How do we find out most expensive? Well, we can use the max aggregate function. We don't want to go and do it by hand. We don't want to just have a look at it and go, oh, that's the most expensive, and just put that directly in. It might change. More records could be added, removed, amended, whatever. So we use the actual function. So we're checking to see if price person night for each row in the hotel table. We check to see if price person night is equal to the most expensive thing. Now, how do we find that? As I say, I could just look at it. At higher, we could have done this task. All the subquery, the basic subquery tasks, we could have done at higher. We did queries of queries. In Access, you can save a query and then you can query its results. And this is the exact same idea, exact same. So we're actually going to, because we can't use aggregate functions in the where clause, we're going to use a subquery. Okay, so our subquery is basically find out the maximum price per night in hotel. That's all that's doing, and the subquery always gets executed first. Okay, and that's it. So if this is essentially replaced by whatever the maximum price is, then we're looking through, we're finding price person night equal to the maximum, and we're displaying these fields. It's beautifully laid out, isn't it? And there's no grouping or having or order by or anything in this. So let's actually look at implementing it. So that's what it looks like to implement it. Okay, so subquery we just put in brackets in there. So that's this subquery here is going to be evaluated first. So let's just look at evaluating it. So I'm just focusing on the subquery here. Select max price person night from hotel. So it's going to go through hotel. It's going to check the price person night. It's going to find the highest value, and that is 179. So this is the result set from the subquery. Now that essentially just goes in place of the subquery. And now the main query can be evaluated. And that's a simple query. That's a NAT5 level query. Right? That's all it is. So go through it, find anywhere price person night equals 179, which is this one, and display those fields. Now remember, the reason we couldn't do that just all in one query is, well, we did it all in one query with a subquery, but the problem is, the reason we had to use a subquery was that we can't use aggregate functions in the where clause. Okay, I hope that helps. I think I'm finished. See ya.